Okay, so in today's class, we will be discussing the images part. Images part we have discussed already quite in detail, but I just want to give you a recap for the calculations area. So basically, if I am discussing images with you, you all know that images are of two categories. One is a bitmap image, the other one is a vector image. So, for example, if it is a bitmap image, it is created out of pixels. So, what is basically the color depth? The color depth is basically to be known as the number of bits used to represent the color in a pixel, right? Color depth is the number of bits used to represent the color in a pixel. You need to understand that images are created out of pixels and pixels are created out of bits. That means that if I'm referring to the color depth of something, color depth means that how many bits. Color depth basically means how many bits are being used to represent the color in a pixel, right? And that color could vary if it is a darker shade or if it is a lighter shade. For example, 8-bit color depth can represent 2 is to power 8 to 56 colors. For explaining this, let's come over here. I have a formula, and that formula is basically to be known as 2 is to power color depth is going to be like the number of colors. So for example, if you have an 8-bit color depth, for example, if you have an 8-bit color depth, or for example, if you have a 4-bit color depth, or for example, if you have a 6-bit color depth, and the question says that you need to define the number of colors. So for solving that, what you are going to do is that you are going to use this formula. So you are going to take the value of 2 with the power of 8, and the number of colors that are going to be right here is going to be 256 colors. That means that if I multiply this 8 times, so I have this much colors, this much colors. Other than that, if I discuss with you 2 is to power 4, so 2 is to power 4 is 16. That means the number of colors are going to be 16. And if the color depth is given 6, this is going to be 1, 2, 3, 4, 5, 6. So 6 is basically 64 colors. So this is how you can calculate the number of colors. Then apart from this, I have the bit depth. Bit depth is basically the number of bits used to encode a single pixel. For example, again, if you have an image, that image has pixels, and if I'm referring to the bit depth means that how much, like how many bits are being used for encoding a single pixel, right? That means that if there are more number of bits, there are um, a good quality of a pixel. How it determines? Pixels are created out of bits, so if there are more number of bits, there has to be a more good quality of pixels. So we will be discussing bit depth in terms of images and sound. Both of that, sound is not we have done right now. I will be discussing that. So bit depth is basically the number of bits used to represent the smallest unit. So for example, if it is an image, so if its a bit depth is larger, that means that the quality is higher. We have discussed this in detail. I was just giving you a recap. So I just want to share some extra material with you. So for example, right here, you can see that this is basically a diagram. So in this diagram, right on top of it, you can see the color depth. then you can see the example, then you can see the description, and then you can see the number of colors per pixel. So for example, if uh, the color depth is 1 bit. Now, what 1 bit means that 2 is to power 1 is equals to 2. That means that if the number of colors in an image is only 2, that means that it is going to be a monochromic image. Monochromic image basically means that it stores only the black and white color. So, if I'm storing the only color black and white, it has to be a monochromic image. Other than that, I have if the color depth is 2, so I'm going to take 2 is to power 2. It makes 4 colors. So again, if it has 4 colors, you can see that it is an RGB one. RGB stands for red, green, blue. And if it's a 4 color, you can see that this one is much better than this because it was a 1 bit. It was completely sort of a disturbed color, monochromic, only black and white. But if I'm referring to this area, you can see that I have 4 colors right here, but still it is not something that I can say that it is even closer to reality. But if I have the color depth of 4 bits, now you can see that 2 is to power is 16. So that means that if I have a more number of colors, if I have a more number of colors, so that means you can see that your image is quite closer to reality. As I'm zooming in, just to telling you that the real difference between these images. So for example, if it is an 8-bit, you can see it right here that if it is 8 bits, so 2 is to power 8, the number of colors per pixel as per the formula is going to be 256. And if the number of colors are going to be 256, that means that the image is closer to reality, as you can see right here. So even if I increase it to 24, you can hard to see any difference between reality, right? Like that means it has a lots of colors. So similarly, if you just keeps on increasing the color depth, this means that more amount of color is going to be added. And if it is increasing, you are making it even closer to HD, UHD, or the 4K resolution as well. So it seems pretty obvious that the higher the color depth, the closer the picture will look to reality. This is the formula. Now for the calculation part, I have some questions given right here. This is the question number 1. This is example number 1 that we are going to discuss in today's class. So for example, if you want to calculate the file size for different color depth. So for example, this is the question. The question says that for the image using 4 bits to store the color for each pixel, then the image size would be. So you need to write down this formula into your notebooks that if you want to find the image size, what you need to do is that you need to multiply the number of pixels into color depth. So for example, right here you can see that the number of pixels are given to me right here, that is 67500, and the bits were given into the question. So if I multiplied both of them, I have the answer, that is the image size of my but in the bits, right? So here is yet another example, and in this example it says that for the image using 24 bits to store the color for each pixel, image size would be. So here I have given that the color depth is basically 24 bits, and what is the number of pixels? The number of pixels are 67500. If I'm going to multiply them, this is going to be my answer, 162,000 bits. So here is another question. It says that for a color depth of 8 bits. So this is how the exams are going to be asked into your question, into your paper. That if you have a color depth of this, how many colors could each pixel store? So for this, you are simply going to apply the formula that 2 is to power is equals to number of colors. So you can easily extract the number of colors, that is 256. Here is another question. Now, this question is something different. This question says that how many bits does the color depth have to be if you wanted to store the 64 colors per pixel? That means that now, as per the formula, which is 2 is to power color depth is equals to number of colors. So for example, it says that if the colors per pixel is 64, what is going to be the color depth? So it is simple that when I take 2 is to power 6, when I take the color depth 6, I have the answer 64. So the answer is going to be 6, because 2 is to power 6 is 64 colors, and this is what it was asked into the question. So 2 is to power 24 as well. Like you can see that these color combinations, they provide you with a different combinations. So here is another question. It says that the bit depth of an image dictates how many different colors can be represented by each pixel. There is a bit depth, and it says that how many different colors can be represented. State the number of different colors that can be represented by a bit depth of 8 bits. So again, you have to put the same formula, 2 is to power 8. 2 is to power 8 is going to be 256 is going to be your answer for this question. Other than that, we have covered this already. Types of encoding: monochromic means only 1 bit, only 2 color depth. It means that it stores only 2 colors, either black, either white. If it is 16 colors, this is mostly 2 is to power 4. If it's 256 colors, it's 2 is to power 8. As far as file header is considered, we have discussed that file header is the one that is responsible for having your important details of the file, such as width, height, measured in pixels. For example, in your exam, you could also be asked like, what is the resolution of a 100 pixel by 70 pixel image? So you can easily solve it by multiplying it like this. So you will have your correct range of pixels like this. So let's work out on the calculations part as well. So here is a worked example. This worked example says that I have a bitmap image, and that bitmap image has a width of 100 pixels and a height of 50 pixels. Now the image resolution or the pixels it has given me, it is 100 into 50. The file header uses 60 bytes. This is the resolution. The file header is basically of 60 bytes. The image is encoded as 256 color image. Calculate the file size in kilobytes. So for doing this, the first thing that you are going to do is that you are going to find the total number of pixels. For finding the total number of pixels, what you simply do is that you simply multiply 100 into 50, and right here you have the total number of your pixels. Now, you know it that each pixel is stored with 1 byte. That means 1 byte is equals to 1 pixel. So for example, if 5,000 pixels are being used, that would mean that 500 bytes of data is being used. And for calculating the total file size, what I'm going to do is that I'm going to add my pixels data. My pixels data is 5,000 plus the file header size. The file header size which was given right here, which is 60 bytes. So if I'm going to add it together, I'm going to have the final answer, which is going to be 560 bytes. And if I want to convert this into kilobytes, so how I'm going to do that? For converting bytes into kilobytes, I'm going to take 5,000 bytes and I'm going to divide this by 1,000. So students must consider dividing by 1024 instead of 1,000 if the file size is in KB instead of kilobytes. So this is some precautions that you need to take. That means that you should consider dividing by 1024 instead of 1,000 if the file size is in KB instead of kilobytes. But right now I think we are referring to kilobytes. So if I divide again 5,000 with 1,000, the answer I have right here is 506 kilobytes. So this is the final answer. I hope this working example is clear to you. So I have here one another example. This example says that I have an image. This image has a width of 2048 pixels and a height of 128 pixels. So the resolution given to me is 2048 and the height given to me is 1028 pixels. Again, what is the size of the file header? The size of file header is 100 bytes. The image is saved as a 24-bit color image. Calculate the file size in kibibytes. So first of all, what you need to do is that you need to check the total number of pixels. You can do that by multiplying it 2048 into 128. So if it's 2048 into 128, the answer is 262. The answer is 204 into 262,144. 262,144 is the answer. But right now I need the answer file size in KB byte. So when it comes to a KB byte, each pixel is stored with 3 bytes because the image is using a 24-bit color image. 24-bit color image. So what I'm going to do next is that I'm going to multiply uh, this 2048 with 3 and I'm going to have the final answer. Then again it is going to be simple. I'm just going to add this value with 100 and I'm going to generate the answer. And for getting the answer in KB bytes, I'm just going to divide this with 1024. I hope this is also clear to all of you, but one question could be asked that, sir, in this question they said that the image is basically of 24-bit color image, but what, sir, you have done is that you have multiplied the number of pixels with 3. So where this 3 came from? So for this area, you need to understand that they have provided to me 24-bit color image. 24-bit per pixel means that each pixel is represented by 24 bits of data. So if I'm going to divide 24 into 3, it is going to give me the answer as 24 divided by 3. It is going to give me the answer as right, like 24 bits can be divided into 3 components. And if I'm dividing 24 by 3, it gives me the answer 8. So perhaps what is proven right here is that red, green, blue are 3 components that takes 8 bits or that takes 1 byte to have this solved. So this is how I have broken it down into 3 bits. And I will also mention the written explanation of this in MS Team so that it's quite clear to all of you. Other than that, I have another example calculation that I wish to share with you that is in right into my PowerPoint presentation I shared with you. So this is basically a bitmap image calculation. It says that you can calculate the size of a bitmap graphic knowing the resolution and color depth. Yes, we have done that. As an example, consider the bitmap graphic is needed to fill a laptop screen where the resolution is 136 by 768. If we want a color depth of 24, then the number of bits we need is okay. We are going to, so basically there are multiple ways for solving that. Right here they have given 24. If you wish, you can convert it as well, but they have just simply multiplied it. But I don't prefer multiplying it to the exact number because it creates your calculation a lot of numbers and you are not allowed for calculators into your exam. So you can basically either convert it this way or do it my way. The result of the calculation basically shows the number of bits, but a size is always quoted as a number of bytes. So if this is the answer is in bits, if I want to convert that into bytes, I'm going to divide by 8. I'm going to have this as the answer. For converting into KB bytes, I'm going to use 1024. This is the answer, which is in KB bytes. And if I want to convert that into megabytes, maybe bytes, I'm going to divide it back again. So note that calculation has assumed that the color depth specifies the total number of bits used to define each pixel. This is it for this area. I hope it's clear to you. Other than that, here is another worked example. This worked example basically states that you have been asked to create a value for the minimum size of a bitmap image. The bitmap is used is to use a bit depth of 8, and the bit map is to be printed with 72 dpi and have the dimensions 5 inches by 3. We use the information provided about color depth given the number of, in this case the bit depth is 8, which means 8 bits for each component, right? So 24 bits needed for 1 pixel. So if it's 72 dpi, that means 72 pixels per inch. So I'm going to multiply 72 into 5, I have 360. Again, I'm going to add the number of pixels per column, which is 3 into 72 is 216. Therefore the total number of pixels are right here. So again then again the total number of bits is the value multiplied by 24. However, we multiplied by 3. So we just multiplied to it by 3 and then convert it into the KB byte. So you can basically work on it on your own as well. So this is it for the calculation parts. The important formula that you need to remember, I have discussed it already in right here, and I hope it's clear to all of you as well. The important formulas are right here. When you wish to calculate the file size, when you wish a color depth. So this is it for today's class. I hope it's clear to all of you. Thank you so much, everyone.